give me unstructured information, give me imagery, and how much can I take out of that? How much information that is going to make Rob feel a lot more confident when he's making the decision? It's also powered by machine learning.
Welcome to How AI Happens, a podcast where experts explain their work at the cutting edge of artificial intelligence. You'll hear from AI researchers, data scientists, and machine learning engineers as they get technical about the most exciting developments in their field and the challenges they're facing along the way. I'm your host, Rob Stevenson, and we're about to learn how AI happens. Here with me today on How AI Happens is Director of Machine Learning over at Wayfair, Tulia Plumettaz. Tulia, welcome to the podcast. How the heck are you today?
Thank you, Rob. I'm doing quite well. Very excited to be today talking to you about machine learning and how we think about it at Wayfair, how we power use cases, leveraging these powerful tools.
Yeah, of course. I'm really pleased to speak with you because I know Wayfair decently well as a consumer. Within the reach of my arm are at least one, probably more, if I really thought about it, Wayfair items. It's really been a great tool for me and fantastically complicated from a logistics point of view. You're shipping these huge items all over the world, I suppose. So we're going to get into all that. Really excited to chat about it with you. Before we get too deep in the weeds, would you mind sharing a little bit about your background and how you wound up in this role at Wayfair?
Fantastic. So I'm an electrical engineer by training. So in the very, very traditional sense, I started my career building transmission lines back in my home country, Colombia, field engineer. So really boots and engineering hat in the ground. And I really enjoyed the tools, but I realized that my interest was a lot broader. Like, how do I bring, my big passion has always been the public sector. Like, how do I bring this mathematical tools into better decision-making, policy, things that affect millions of people and that you want to do them in the most possible efficient way. So that brought me to New York. So take a plane, Columbia, land at Columbia, but the university, and then pursue a PhD in operations research. And then the way that I see operations research, it offers just such a solid foundation for what today we think about as that broader machine learning science field. So from the theoretical toolkit to you think about problems in literally any space and try to apply that toolkit to solve those problems, efficiency, etc. So from there, the path is pretty straightforward. So at that point, I am in a PhD that is offering the toolkit for that today called machine learning field. Work at a research lab, fresh out of my PhD, jump to the other side, startup. I think those two things give me the kind of like the tools to really jump at Wayfair, that I would call it incentive, a match that happened, right at that moment in time that Wayfair was kind of like really scaling, really thinking about how do we take this brand to the next level. And then from there, it's been just, I would call it a perfect match. Like I have seen the team grow from, I was one of the first hires on the science organization to 200 plus organization of scientists, really powering experiences with ML across our marketplace.
Gotcha. So forgive my naivete here, Tulia, and forgive my naivete could be the subtitle of this podcast. But what is operations research? How did that study take shape for you?
I have a lot of funny anecdotes with that because you many times have folks saying, I want to study operations research. And like, can you tell me what that means?
Right.
So the way that I think about it, I'm not going to go the long-winded story but just think about it as a very broad field in the intersection between mathematics, computer science, economics that is trying to to apply that toolkit to solve real life applications. So from how to get from A to B in the faster possible way, from how do we think about allocating. If you think about people needing kidneys and donors and being willing to do it, how do you do those allocations in a way that is efficient, that serve a general welfare objective? School matching. You need to assign kids to actually schools. How do you do that? So just think about it. You have any problem which you have an objective and you are subject to a lot of constraints and you're trying to figure out how to do that. That's a way of describing the broader sort of problems that the field of operations research is trying to tackle. So it's pretty broad. Like it's literally, think about it as a toolkit that you can put in finance, healthcare, education, business, and to look for efficiencies.
Got it. So sort of like a STEM approach to efficiency, logistics, that sort of thing.
That's a way of summarizing it. Yeah.
What was your thesis about?
And I actually use as one of my examples. My thesis was about kidney exchanges. So how can we build algorithms that allow us to make those decisions in a way that is strategy proof? And strategy proof literally just means Rob has no incentive to submit information that is not accurate, like try to trick the system, because there's no way to win by trying to trick the system. So that's what we call, and you want that property when you're making, especially public policy decisions. You want people to have no way to find loopholes and exploit those loopholes. So that's the strategy proofness of algorithmic solutions become really important in those type of applications. That's building algorithms that have those properties was what I did during my PhD.
Is there a term for that when there's no incentive to mislead or try and game a system?
Strategy proofness or strategy proofness.
Proof. Yeah. That's fantastic. Yeah. But as a user, for me, would I necessarily know that? Would I know that I ought to just, I feel like that when you're talking to your doctor, tell them the truth. They're trying to keep you you have no incentive to lie to your doctor, probably, as long as your intentions are your own health, right? But there are people who would disagree with that, right? Or who may not tell the truth to their doctor. Does strategy proofness rely on the user agreeing that it's strategy proof?
No. Strategy proofness just basically ensure that if you opt to not be truthful, you are not going to get a better outcome than if you were truthful. So in overall, so just think about it as when you go to Reddit and you see people saying, hey, these are ways of tricking this particular, there is a opportunity to take advantage or do, some policy abuse. That is the thing that you want to avoid. So it's not something that you openly go saying, this is strategy proof, but rather, well, there is no way that someone can put a playbook on how to trick the system because they're not going to get the outcomes that they're expecting from it. So that's the beauty of strategy proofness is you can guarantee it. You don't need to worry about megaphoning it. You just know that mathematically, there's no way to get a better outcome.
Okay, that makes sense. It wouldn't rely on the user because, say, I didn't believe in the strategy proofness of a system and thought I could game it. If it were strategy proof, I would just lose. So it's like, whatever, like you can try, it's not going to work.
You got it. You will lose or you will be the same that you were. So that's exactly the beauty of it.
What made you focus on like kidneys in particular?
So I've always been passionate about the public sector. So my parents were both, public sector employees. I saw my mom growing through, the ranks in the education sector in my state. So it's anything in that space, especially when it comes to health, transportation, education, has been something that I am always interested in. That problem happened to be a problem that there is that interest, but there is also that, like, what is the problem at hand at that point in time? And that was a pretty hard problem at that point in time. Just matching, you have multiple criteria that you're optimizing for, and that happened to be a problem that matched a lot of my criteria. Got super interested in it, and that's basically a story. Like, not a lot of over-engineering. There's a lot of luck factor landing there.
Okay, got it. When you said a moment ago, Wayfair was just a perfect match, as you explained, your research and your studies, I can see why that's the case, right? You are applying this mathematic and engineering approach to fantastically complicated problems. Wayfair, just as a base of their service, is a fantastically complicated problem. The logistics of sending a couch halfway across the country or around the world, etc. Anyone who's ever bought furniture will understand how difficult and complicated that can be. So I would love to get under the hood a little bit of what's happening when I, for example, ordered this bookcase that I know came from Wayfair. It's just off camera here in my office. How is ML and AI being integrated throughout Wayfair?
Okay, I love that question. So let me get started with it's probably even before it's even before you end up deciding to purchase this. So from the moment of Rob start exploring bookcases, like I'm pretty sure you're not, I found exactly this one. It took me 1 minute to make the decision. No, there is a lot of gotta fit my space, looking at the dimensions, looking at the style, and then there's Wayfair.
Ask my wife permission. Yeah.
All these things. From the moment in which we are deciding, I'm going to go after, I'm going to put marketing on Rob. I want Rob to come to Wayfair, to the moment in which you land and we show you things like, what should we show Rob? How much do we know about Rob? Has he been surfing for a while that I'm starting to get some information on what he could be looking for and what should we be showing him that is going to meet his need, that is going to be the thing that he's looking for, that is going to fit his space. All of that is powered at Wayfair by machine learning. A lot of proprietary algorithms around it. We also have, our partners, but like all that decision making from which channel should I bring you in? How do I bring you back if you're kind of like taking your sweet time to make a decision with us, to really what we show you when you are with us? It's a lot of ML driven. Then you mentioned a bookcase, and I say you gotta have the right dimensions. It can't be bigger than the space that you have at home. So that other side on how do we enable our suppliers to actually get that bookcase into Wayfair in the easiest, simpler, but also accurate way, that when that bookcase gets to your house, it's a material that you're expecting, it's a dimension that you're expecting. We also bring machine learning to that journey. Give me unstructured information, give me imagery, and how much can I take out of that? How much information that is going to make Rob feel a lot more confident when he's making the decision? It's also powered by machine learning. And then the pretty nitty-gritty of logistics. So from, hey, I have these 3 different bookcases. Rob lives in Denver. Which one is the closest to, where he is? Should I put that one a bit more on top so he get it faster? It's better unit economics for Wayfair. So it's a win-win for our customer. They get what they're looking for. They get it as fast as possible, and we can keep it cheaper, which means we can actually offer more competitive prices to our customers. So all of this machinery, it's powered by machine learning at Wayfair.
This is, by the way, the process you're outlining. This is like the platonic ideal of like cookies and tracking and like data sharing for the consumer. It's like, look, if my data is being used in such a way that it makes me more likely to get the bookcase I want, if it makes it easier, then I'm okay with that. It's like this other stuff about like, oh, well, you're harvesting my information and then selling it to BlackRock or something. Like then people start to object. But there's lots of consternation about the value of the data I'm creating and sharing my own personal data. However, in this case, I'm okay with it because guess what? I got this great bookcase that I love. So if it does help me, it's exchange for a service, right? And so it created this value for me. So I wanted to call that out. That's sort of the process that I like to hear about because it does help me as a consumer. You mentioned that there's this problem of unstructured data, unstructured imagery, which is interesting because that is like a universal problem, an industry agnostic problem in machine learning. What do we do with this unstructured data? So could you give examples of what that means when Wayfair is experiencing that? And then how are you kind of ironing it out?
So for Wayfair, so when I think about selling batteries, and this is just to pick an example, it's a commodity, it's a product that is like pretty easy to describe. If it gets to your home and it happened to be that you were looking for a AA and by mistake, we end up shipping you a AAA battery, returning, it's really cheap. Like it's just a small good. Now I have a sofa. How do you even describe the sofa that you're looking for? Even you have an idea, but it's a space that it's not, brands are not the first thing that come to mind. It's very inspiration driven. It's very much the thing that fit a bunch of other things in your space. So they trying to get that to you without you touching that sofa, without you being able to sit on it, feeling it. It's one of the big challenges that we have. And at the same time, having that super large assortment, we want to make sure that for our suppliers, when they are trying to get their product, we're not adding that complexity to them. Like imagine, telling them like, just tell me everything about this sofa such that Rob, or that bookcase, such that Rob feel that he knows everything about it. Patterns, texture, rounded edges, the material, the type of how the wood plates are actually put together. And that's where the machines come in the middle, trying to help, offering you that nuanced, rich information that will make you feel it without physically feeling the good, without adding complexity and actually inconsistency on how a supplier will be describing those products. So that's an example in which, to say, it's a universal problem. You're selling something, you need to be able to characterize it, but it's particularly nuanced for us because of that bulky item that if I get it to your home and you don't like it, I'm in a pickle trying to get that out of your home, the cost, et cetera, et cetera. So it's particularly important that like, it's really hard to describe. It's really hard for you to like feel confident about it. And I'm trying to surpass those barriers and like guaranteeing that when that get at your home, it is what you're looking for.
Gotcha. So in that example, from the original like producer or the seller, Wayfair has all this information about, for example, a couch, right? Most of which I don't need to know to make a decision about buying a couch, right? So is that part of the unstructured data problem? Is like, let's take this corpus of data from about furniture and home goods and sift out the things that someone like Rob needs to make a decision?
That's just one aspect of it. So you are right. I have an ocean of information. Some things are just really relevant for Rob to make the decision. But there's also that ocean of information lacks some nuance on what is needed for Rob. So imagine, I'm going to give you a very simple example. You found out about this color called cerulean. You love it. It's some sort of blue. It's a trendy blue. So you are looking for a cerulean sofa. Rather than asking my supplier to know the nitty gritty about that blue that they're producing also being called cerulean, we have the machines powering that. So when Rob is looking for cerulean, I'm able to show them all rich cerulean offering of sofas rather than relying on, did that supplier knew that this is called cerulean, so they actually put it there, and then that's how I end up showing it to Rob. So that's actually a pretty neat example on the enrichment of information. Just think also of patterns. Let me show you all the chevrons that we have. Do I need to rely on the supplier knowing that this is chevron and making sure that word it's exactly, stated in the information? No, I can use the image to actually extract those patterns and offer it to Rob. Hey, you want a chevron sofa? You got it here. We have super rich assortment of those.
So the problem is not merely let's cut down the information available so that Rob is not overwhelmed when he's buying a couch. The problem is also maybe we didn't get enough, and we don't the one thing that Rob needs to know, whether it's cerulean or not, is not in there. The problem is there's too much data. It can also be there's not enough data. With the enriching, so your job is to kind of get to the Goldilocks zone of the information about some of this materials.
Exactly. And even if the information is there, at the top, you could tell me this is 1 meter long table, and then just 3 lines below in your unstructured information, it's say 1.1. And then that difference of 10 centimeters, it's actually a big deal if you're living in a small apartment. That's the thing that makes the table fit or not. So even just coming back and saying, hey, something seems off. I have 2 pieces of information that are contradicting each other. Help me to sort it out. So there's a validation component, there is an enrichment component, and there's actually an extraction component. That's how I will put together that full surface.
That's a great example. The description says 1 meter, but it's actually 1.1. And maybe the real, the specific dimensions are listed somewhere else. So you have both examples of the data. You may not, it might just be wrong. But that's a great example because that strikes me as the kind of thing that's maybe you only became aware of it once it became a problem for someone. That's a lot of software development is it broke for the user. Now we can go back and fix it. We didn't see that when we were in testing burst, and then it gets into production. Now there's all these problems, right? So I'm curious, is that a process of things breaking, going back and fixing them? Or are you able to train your technology to look for these kinds of problems before they end up sending me a table that doesn't fit?
So the latter, that's the North Star. That's where we want to go. Think about it as a journey. So we want to be in a place in which as early as possible, before problems actually even exposed to our customers, we're able to detect them. So you are adding that product. I extract all that information. Oh, something it's actually not quite fitting between the dimensions you're giving me and the weight of the table. So imagine that, you make 1-0, and instead of something being 100 grams, it appeared to be 10 grams. And that makes no sense given the type of good that you're trying to add. Then being able to quickly interact with you as, or supplier or partner and say, hey, something seems off here. Let's just check it. Let's just correct it because something seems off before it gets to a customer that actually end up having to return an item or to be unhappy because we didn't meet their expectations. So that preventive nature, it's where actually ML play a big role. Once things happen, then you end up into corrective measures. And that gives us a lot of training data, but success means we are able to prevent those.
Could you speak more about that preventative approach? How are you teaching the machines to see around those corners?
Great. So we need feedback loops. The reality is, I'm going to go to that example. You have the bad outcomes, so the outcomes in which for sure there was a problem. those become examples. So call it positive examples of a problem. And then the majority of the cases is going to be you don't have a problem. Or if you have it, you're not actually aware of it. So that data, it's a fundamental piece on even starting to think about we can build something that is able to detect. Like you need to be able to say good versus bad in simple terms. So once we are, and so there's a lot of efforts in how, we jumpstart ourselves with training data, but also, how do we actually enrich it, evolve it over time, et cetera, et cetera. And then you start integrating that into your process. So just going back to our example of dimensions, you build the first version. I call it the crawler. It's like a baby that can't walk yet. It can run, definitely, but it starts to crawl. And that you say, well, I'm going to expose it to a small number of my suppliers, or I'm going to expose it to a small number of classes, the ones in which I am good at detecting when dimensions are wrong. So I'm going to give you an example. For things like table, things that like the shape of the good is like pretty boxy, like three-dimensional and standard. It's a well-behaved class to be able to say, a table that has a meter versus 10 centimeters, detecting outliers there seems relatively easy. You have the density of the material. You have so you have a lot of information that allow you to start making inference on. So at the beginning, you start deciding, do I go really safe and only flag things that I feel are like absolutely wrong? If you do that, you feel really good because you are like, oh, I'm doing really well. I'm very accurate. But then you leave a lot on the table. So then you start, going deeper in that spectrum and saying, I am going to flag things that are like potentially right, but I'm going to collect training data. So my supplier is going to tell me, there's nothing wrong with my dimensions. They're fine. And then I take that as you know what? This is a positive example. Like there was nothing wrong with, this is a negative example. There was nothing wrong with this particular table. You start enriching the training data. So you start moving from that crawling to that kind of like starting to walk, and it become a multi-quarter, multi-version, evolution of a lot of these capabilities. So the idea of like 0 to it's working really well is not how it happens.
Right. I'd love for you to give an example of some of the things that are a little more nuanced when it comes to outlier detection. You said that, if we detect the things that are more cut and dried, like weight and dimensions, that's great, but you leave things on the table. What are the things you might leave on the table?
Yeah. So there is always edge cases. So think about one-of-a-kind items. So items that are like really non-conventional, like an area rod that it's like extremely skinny and long, and it's used for a particular purpose, particular corridor.
Here's a lamp that's shaped like a unicorn.
Oh, don't get me going on accents. Like accents is the perfect example in which accents is actually one of those, call it, group of products that like detecting outliers, it's just really hard, period. Like it's such an heterogeneous space. And I think that's where the more homogeneous is a particular space, call it tables, etc., the easier we're able to say, you don't look like the mass.
Yeah.
The more heterogeneous is a particular, so accents like figurines and bases, all these things that you are like, the whole point is that this feel like one-of-a-kind pieces. That's where it's less suitable to actually bring machine learning to the picture. So like we rely on patterns that are repeatable, detectable. So the homogeneity of things, it help you to say, if you are out of the norm, that give me, and I need a lot of data to say what looks in the norm and what looks outside the norm to be able to detect those outliers. So one-of-a-kind items are some of those. Some are actually just funny situations, like a sofa that is designed for kids. So it happened that it entered our system as a sofa. It's indeed a sofa, but the dimensions are
tiny,
for exactly. It's tiny. It's tiny, and if you didn't look at the dimensions and you bought it, or if we got it wrong for some reason, it shouldn't have been in sofas. It should have been in kid sofas. Those are actually typical examples that, or we flag by mistake because indeed those are the right dimensions, or we don't flag and it ends up being things that should have been flagged. It's not in the right category.
Yeah, that makes sense. I have a similar experience with that. A friend of mine bought a tennis set, and it was like a tennis racket and like a cute tennis skirt, a tennis top, and a headband. And she's like, can you believe this deal on this tennis set is only $70 for all those things? And so she buys it and it shows up, and it was an outfit for an American Girl doll. So she's like, I could maybe wear the skirt as a hat, but the rest of it's not going to work.
Yeah. So like the anecdotal ones. I think the accent example, it's probably the one that I would say at scale, it becomes really hard. So then that's where you start making trade-off. Is this problem suitable for an ML application? And is the value that we will get justifying the investment on making it work? So let's make it work for tables and sofas and those bulky items in which returning become really hard. But if accents is not only hard to make it work, but actually the risk or the exposure of getting it wrong, it's lower, then you start making those trade-off on where do you do your investments.
Right. Yeah, by its very definition, an accent would be an outlying piece of data, right? That's kind of the whole point of it, is like it's a one-off thing. So that makes sense. And your internal term for like tables, for example, I think I caught that well-behaved class.
This is me using that to create some intuition. I think about them more as like more homogeneous classes versus more heterogeneous classes. And classes, just think about it as a group of products. I want to refer to a thing that people used to sit, and roughly is in this category. That's a sofa. If it's only 2 seats, then it's a subgroup of that mega class, and that we'll call it a love seat. So it's more about how do we create common understanding or taxonomy on referring to this very broad space that is the home goods category. So the well-behaved, it was me just saying, hey, we all know how a table for a dining set look like, and you can get creative, but there's a lot of boundaries. It's pretty well ring-fenced. Meanwhile, with something like accents, you have a lot more of the variability, heterogeneity in how it can come, in which shapes.
Sure.
Sizes.
I was tickled by that, the well-behaved class, because you as opposed to what, like a naughty class, like the accents, but it's like well-behaved. Who's to say? It's well-behaved for Tulia's needs anyway.
Here's the scientist in me. It's similar to these are actually in mathematics. There is a lot of properties certain problems have certain properties, and there is the behavior wording around describing when a problem fit really nicely certain type of properties versus not. So that was just the nerd in me coming out.
Yeah, I like that. Tulia, I'm realizing a moment ago when you were sharing about what happens when I go looking for a bookcase, one example was, we know Rob lives in Denver. Let's rank bookcases that are closer to Denver. He'll have a better experience. He'll be more likely to buy a bookcase closer to him. That's one example, but that seems like a pretty sophisticated search ranking, a lot more sophisticated than what I'm seeing in other kind of search experiences. So clearly Wayfair has this bespoke search tool. I'm curious to hear more about that, and maybe we can start with it. When did it become clear that Wayfair was going to need its own approach to search?
Perfect. So let me start with confirming that we built a lot of customization on our space. And a lot have to do with just think very generic around, if you're looking in a general purpose e-commerce site, you sell all sorts of categories. The level of the specialization that you need when you are trying to get deeper into a particular category, and the bespokeness, the nuance, what matters for someone who land on our site, they know we are all about home. We are not selling batteries or selling food. It's all about home. The ability to offer that bespokeness, that nuance, that deep understanding of our space become fundamental. So that's where, customizing our algorithms to actually show that we have a deep understanding of that space. And when you look for Cerulli, and going back to the example earlier on, that we actually are able to provide, we show that we have expertise on color and colors that are used to describe, the home category, or just styles that are popping up, trending, and that you come and you're able to see that assortment easily, in front of you. That's basically the nature of why we need customization. When did we realize that? That's just pretty much in the bread and butter and of how, we have always thought about
making a better product, it sounds like.
Exactly. It's at the core of how we thought about our space. Is we have this challenge of making you buy something that you will traditionally feel, see it, touch virtually from the comfort of your sofa. How do I do that? And richness of information and easiness of finding that, not only search, just filtering, exploring. I want, modern, but I also want it in this color, but I also want it became at the core of how we conceptualize our product and the ability, making it easier for our customers to find us. So I would say just at the core of our space, we knew that making easier to navigate this very inspirational space was going to require customization.
Right. Tulia, I keep bringing up my bookcase. It's now a recurring character on this podcast. I should set up a microphone for it. But the reason I keep doing it is because I love it. It showed up on time. It's just a testimonial of Wayfair working, and specifically the search algorithm working. So I'm curious, when you are tweaking this, when you are working on the bespoke search tool that you have over there, what are you looking at to kind of measure its success and improve it over time?
I'll start by saying we have a pretty core and strong culture around experimentation. So a lot of it is around, we test things. Making something work or not, they are like high cardinality problems. So like so many things can go into making this experience better than the experience that we had before and the algorithm that we had before. So basically we go in a culture of saying, okay, this is what we're seeing out of this particular algorithm. This is what we are seeing. These are classes that are working really well. We're seeing, customers are finding things easier. These are some that are not. How can we address a particular gap that we have? Let's design a new algorithm. Let's go and test it. Because at the end of the day, we just have a hypothesis on, what we are seeing through the data. And then we build little things for generally one generalization. Like that's a beautiful property. One thing that works for a lot of things, or fewer things that work for a lot of things. So then it becomes that trade-off of, well, this new algorithm actually improved this particular, smaller class, but actually came at the detrimental of the broader. How do we move forward? How do we start maintaining our general objective of Wayfair, unit economics, profitability, and at the same time balancing all the other constraints that that you're looking to have, which is we have happy customers, we have the right unit economics, we offer you the right diversity. It's easy for you to find products. And that's a lot of the fun on the journey, in which it's very multidimensional what we're trying to do. So testing allows us to actually keep ourselves very rigorous around how are we trading things off between those different dimensions. So it's really at the core, it's a very exploit and explore type of process with a lot of hypothesis testing. Testing, it's at the core of us being able to say this new version, it's better than this other version in these dimensions. And we're taking a trade-off on these other dimensions.
Got it. Exploit and explore. I love that. And every mark gets a little bit better. That's fantastic. Tulia, we are cruising well past optimal podcast length here, but it's just because I've had a really lovely time chatting with you. Before I let you go, I would just ask you to speak to some of the folks out there in podcast land who are forging their own careers in machine learning. What advice would you give folks as they continue on in this space?
Here's the advice that I generally, it's going to be pretty generic, but like I actually think it's very first principle one. It's think about the problem you're trying to solve. Like it's really easy to get distracted and attracted by the toolkit. And going back to first principles, like what is the problem? How do you break it in components? Machine learning is one of the tools. There's so many other, things in the toolkit that you can use to solve these different components. Think about what is success in solving the problem in this particular component. And then the system, comes all together. So that would be, I think, the most common misconception that I see out there is that it's all about the techniques. There is space for that. If you are doing research in a particular field, like it's absolutely about the particular topic. It could be very specific on a technique but when it comes to really practicing and applying ML into industry use cases, I think the not losing sight of what is the problem that you're trying to solve. How does it fit in the business that you are in and the peculiarities, the nuances of that. I think it's been something that like I rarely see not being kind of a nice playbook for delivering the value that you're expecting.
That is great advice. Tulia, I have loved chatting with you today. This has been a fantastic conversation. Thank you for being here today.
Thank you for inviting me, Rob. This has been a pleasure.
How AI Happens is brought to you by Sama. Sama provides accurate data for ambitious AI. Specializing in image, video, and sensor data annotation and validation for machine learning algorithms in industries such as transportation, retail, e-commerce, media, medtech, robotics, and agriculture. For more information, head to sama.com.